So in 1.9, we're going to do a little review on graphing. Okay, so if we have a equation of y equals 2, so if we were going to make an xy table, that's just saying at all points y is 2. It doesn't matter what x is. X could be -1, 10, 0. Y is always 2. So these are the horizontal lines. And then if we have an inequality here, that's saying it's any y value, every single y value that's less than 2. And remember, any x can be anything, and y is any number less than 2. Okay, so this we shade everything down there below. Now, if this had just been y is less than 2, we would have had a similar graph, but it just would have been a dotted line and then shade down there. All right, so let's look at this one. X is -3. That's saying at all times x is exactly -3. So that's a vertical line at -3. And the distance formula, we're going to just use this so much as we move on in math. So I wanted to show this again. And so we've got which point is closer to the origin. So we could graph them and kind of get a ruler out and look at it, or we can just use algebra. So here I've got -2, -1, and then I have 0, -3. So this is point P, and this is point Q, 0, -3, and 2, -1. All right, so looking, to me it looks like P is closer, but let's just actually measure it. So we're going to go from the origin. We're going to find the distance from the origin to P. That distance is going to be square root of, I'm just going to call this one x1, y1, and this one x2, y2. So it's going to be the difference between the x's. So I've got 2 minus 0 squared, and then the difference between the y's, -1, minus 0 squared. So that is 2 squared is 4, -1 squared is 1. So OP is the square root of 5. And now let's do from the origin to Q. So that is, well, that's just 3, right? We can just count that. Okay, so that's 3. Now, who's bigger, square root of 5 or 3? If I'm looking at what is 3 equivalent to, that would be the same as square root of 9. So 3 is definitely bigger than, square root of 9 is bigger than square root of 5. So Q is further. So that means that point P is closer. Okay, moving on, let's look at midpoint. So in Math 103, we just found the midpoint between 2 points, but in 135, it's always just the similar but a little bit trickier. From this one, we need to actually figure out what one of the missing points is. So we've got the midpoint. That's at -4, 1, 2, 3, 4. 2, 3, 4, 5, 6, 7. So that's the actual midpoint. -4, 7. Okay, and what we need to do is find Q. We have P is at 0, 3. And we need to find Q, which would be out here somewhere. Okay, so the midpoint is, you just add up your points. Q is at some x, some y. So you add up your x's, x plus 0, and then it's the average of those. So divide it in half. Add up your y's, and that's the midpoint, which is given. That is at -4, 7. And I'm just going to break it down and look at the x. So x plus 0, that's just x over 2 is equal to -4. And multiplying both sides by 2, we get x is -8. And then same thing with our y's. Y plus 3 over 2 is equal to 7. So multiplying both sides by 2, we'd get y plus 3 equals 14. And subtracting 3, we get y is equal to 11. So that tells us that the point Q is at negative 8, 11. So in this class with graphing, we're going to be looking at all of the shortcuts. And so before we do that, we just need to do a quick review on just straight out graphing. So if you're given a line 2x minus 5 is equal to y, what I like to do is just get this set up in y equals mx plus b, because the coefficient of x, that's the slope, the steepness, and then b, that looked like a 6, but that is the y-intercept. So we're actually in that format. It was just written backwards. So y is equal to 2x minus 5. So that means that the slope is 2. And it's nice to have slope written as a fraction, so I would just think of that as 2 over 1. Okay, and then the y-intercept, the y value is negative 5. To be a y-intercept, you need to have 1, 2, 3, 4, 5. The x has to be 0. Okay, so that's our b, that's our beginning. And then we move from that point up 2 over 1, 2 over 1. Okay, 1, so it would be up here. Okay, and then just remember, we can always pull out an xy table, 0, 1, 2, just put some easy points in there and then calculate them. 2 times 0 minus 5, that's negative 5. 2 times 1 minus 5, that is negative 3. And notice that we're getting these points that we did using y equals mx plus b. 2 times 2 minus 5, that's negative 1. All right, now here, x, y, we're going to use a shortcut on quadratics. This minus 4 is just going to slide our graph down, but let's just do a quick review on what the original parent graph would look like. Okay, so we're going to pull out our xy table, plug in a value of negative 1, square it, and calculate out what the y value is. So that would be negative 3, 0 squared minus 4, negative 4, and here we have 1 squared minus 4. That's negative 3 again. So we have 1, 2, 3, 4. And then going here, we can do another point. 2 squared, that would be 4 minus 4. So there's a y-intercept. And then we have a mirror image right through the vertex. So if I have a point that's over 2 units along the positive x-axis, I'm going to have a mirror image. And then just remember, when you're graphing, you need to connect it with a nice smooth line with arrows, because our x values, we could have chosen any infinite number of values. And let's do one more, absolute value. Okay, so we'll pull out an xy chart, and we'll just do a few of these. I'm going to make it a little bigger so I can kind of see what's going on here. Okay, so we have absolute value of negative 2 minus 2. That would be absolute value of negative 4, which is 4. Negative 1 minus 2, absolute value of negative 3 is 3. 0 minus 2, that is 2. Okay, oh, these should be positive. So I have 1 minus 2, that's negative 1, so that'll be 1. And 2 minus 2, that's my 0. And I didn't really go far enough. 3, 4, 3 minus 2, that's 1. 4 minus 2 is 2. Okay, so 2, 4, 1, 2, 3, 4. Now I'm just going to plot these. 1, 1, 1, 1, 2, 0. And then we start going back up. Okay, so we've got a mirror image as well through, it's not called a vertex for absolute value, it's a V shape. And what we're going to go in and look at is when we mess with the input, the x, that slides our graph left and right. And when we mess with the output, like we've already done our calculation for x and then we subtract something from it, that slides it up or down. So we're going to get into some of those transformations on graphs. So that's just a little quick preview of some of the stuff we're going to get into. There's our... All right, let's review intercepts. So those are where those cross the x and the y axis. So if we want to know where it crosses the x-axis, we just need to set y, plug 0 in for y. So for my x intercept, we're going to plug y equals 0 in. Okay. So here we go. We're going to replace my y with 0. So 0 equals x squared minus 2x minus 3, and then I can factor. Let's see, so that would be x minus 3 times x plus 1, and then using 0 factor, 0 product property, I get x is equal to 3 or x equals -1. Okay, so my intercepts are when x is 3, we have a y value of 0. And also when x is -1, we have a y value of 0. Okay, so those are my x-intercepts. And then for the y-intercepts, you're going to plug x equals 0 in. So I'd have y is equal to 0 squared minus 2 times 0 minus 3. So y equals -3. And that tells me that when x is 0, y is -3. So that's my y-intercept. All right, and those are really helpful as we go through and graph, because at least those are nice, easy points to find on the graph. Okay, so then for circles, that's another thing that we want to look at that we covered in Math 103. Okay, so here's our general formula for circles is right here. Okay, and whatever you're subtracting from the x, that's the x value of the radius or the center, and then whatever you're subtracting from y, that's the y value of the center, and then we have r is the radius. But sometimes our graph is not, our equation is not set up to be easy to look and just tell what is the radius, what is the center. So we have to do a little algebra to get ourselves set up. Okay, so the first thing is to get all the variables on one side and move 8 to the other side. Okay, so x squared, I'm going to move everything x-ish, xy together, and give myself a little bit of room. Okay, and the 8 I moved over to the other side. Now I'm going to complete the square. Both. Complete the square. So in this case, I just have to do it for x. Y doesn't have anything else. It's just y squared. So this is all set up y minus 0 quantity squared. Okay, but my x, I need to complete the square, and the way that we do that is we look to see what's the coefficient in front of the plane x, and what we're going to add to both sides is you not exactly that number, you take that number, that 2, split it in half and square it. Okay, so what we're going to add to both sides is 1. That's completing the square. Okay, and then next thing we do is we factor. Okay, so this whole expression now can factor as x plus 1 times itself, so quantity squared. Okay, and then we have the plus y squared. I'm just going to show that as y minus 0 just to show you what the center is. Okay, so the x value of the center is given by that, and the y value of the center is given by whatever is being subtracted from y. Okay, so my center, it's actually going to be -1 for x and 0 for y because the general formula has a minus there. So really what's going on is we have x minus a -1. That's how we got that plus there. All right, so there's my center, and then the radius is not 9, it's the square root of 9, so the radius is 3. Okay, now once you have that information, then it's really not hard to draw the circle, because we plug in a radius is -1, 0, and then we count out a radius of 3 in each direction. And then just try as best we can to draw as nice a circle as we can. And there we have it. There's our graph.